Hey everyone, today we are looking at 12.2, which is going to be about arcs and chords. So we are continuing our work with circles right now, as we will for all of chapter 12. So the first thing that we need to look at in this section is what is a central angle. So a central angle is any angle in a circle whose vertex of the angle is actually at the center of the circle. So if we look at this circle, B is the center of the circle. And then I have an angle that is ABC. So angle ABC is a central angle because B is the vertex of the angle and the center of the circle. All right, the next piece that we're going to look at is what an arc is. An arc is the part of the circle that is contained between the two sides of the angle. All right, so the distance around from A to C, this red piece right here is called an arc. Now, we have three different types of arcs. We have a minor arc, and a minor arc is going to be a measure that is less than 180 degrees. So anything between 0 and 180 is going to be a minor arc. Now, the way that we name these arcs is we're going to write the letters and we're going to draw this little arc symbol on top of it. So if I'm just writing arc AC, I'm going to write an AC and I'm going to draw an arc on top of it. If I want to write the measure of the arc, which is its degree, just like in an angle, we're going to put a little m in front of it. Now, with minor arcs, we are going to name them with only two letters. All right, so and those two letters are the endpoints of the arc. Now, arc AC is the same as arc CA. Just like in a segment, how it doesn't matter which order you name it, an arc is going to be the same way in that sense. Okay, so minor arcs, arc AC, arc CA, they're the exact same thing. A major arc. A major arc is any arc that's measure is greater than 180 degrees. So if it's between 180 and 360, then that is a major arc. Now, when we're naming a major arc, we're going to use three letters. All right. The way we pick those letters is it's going to be the endpoints of the arc are on the outside, and then any one point on the arc will go on the inside. So if I look at this one, my endpoints are A and C, so they go on the outside. I have point D somewhere in the between those two, so I can say either arc ADC or CDA. Those will be both the same. It doesn't matter which way we go. Now, let's say we had another point on here, E. I could say arc AEC or CEA, but I would only use one of these 2 points. Okay, I could have 10 points in here, and I would only put one of them in between arcs A and points A and C. All right, so when we're doing a major arc, we're using three letters. Now, our next type of arc is a semicircle, which measures exactly 180 degrees, and we also name that with three letters. Because if I just tried to say arc EG, I wouldn't know if I was going up or if I was going down. So I would want to clarify EFG, or if I had another point down here that was A, I could say EAG or GAE. All right. But that third point, that middle point, tells us whether we're going up or we're going down or left or right, whatever, depending on where the diameter lies. But know that, again, it is three letters, and we're using the endpoints and then any one point in between those. And again, just like an angle, how you can name an angle like ABC or CBA, the arc can be arc EFG or GFE. All right, so you can switch the order up a little bit. All right, so let's take a look. Now, one thing that we need to know is that the measure of the central angle, let me pop back here for a second. Whatever this angle is, this arc is also going to measure. Okay, so these are always going to be the same. So if this is 20 degrees, then the arc is going to measure 20 degrees as well. All right. So when we look at our example here, we're not looking at this in terms of degrees. We have a pie graph or a circle graph, and we're looking at music sales from a music store during 1 week. Okay, so the different genres and how much they sold. I want to find the measure of arc BC. Well, notice that that's going to be our rap category here. All right. With this piece of our circle graph, it's in percentages. So 13% is not the same as 13 degrees, okay? Because it's 100% to get to the full circle, but it's 360 degrees to get to a full circle. So we need to make sure, first off, you understand that the percent and the degree do not match. All right, what I am going to look at is I know that a full circle is 360 degrees. Okay, I want that wrap piece, which is going to be 13% of that. So I'm going to multiply that 360 by that 13%, and it's going to give me 46.8 degrees. And that is going to be the measure of my arc BC. It's a really weird arc. All right. So again, anytime you're looking for any piece of a circle graph and you're looking at percentages, you want to take that percentage and multiply it by 360 to get what percentage of the circle you're looking at. All right. Now, remember back in chapter 1 when we talked about a segment addition postulate, we talked about an angle addition postulate. Okay, now we're going to see an arc addition postulate. Okay, remember that the segment addition and the angle addition just said basically that you could take two segments or two angles and you were allowed to add them together. All right, that is all the arc addition postulate says, is that, hey, you can take two arcs and add them together. So it's not really that big of a deal. Okay, it's something that you're going to naturally do anyway. So what I want to do here is find the measures of these three arcs and then classify them as, are they minor arcs, major arcs, or semicircles? So what I usually do first in problems like this is I'm going to just find the measures of all the arcs, all right? And then we can go in and fill in the pieces that we need. So I see that this is 90 degrees, so this arc is going to measure 90 degrees. All right, notice that segment AD is a diameter. It goes straight across and straight through the center. So that means that this piece here is also going to be 90. So that means that in order to find the measure of arc BC, I know that BA is going to be 18 degrees because the angle is 18 degrees. So all I have to do is 90 minus 18, and that's going to give me that BC has a measure of 72 degrees. All right, the next thing I want to notice is if we look here, I have vertical angles. Okay, so BFA and DFE are vertical angles because both BE and AD are diameters. So they're going to make that X and create those vertical angles, which means that the measure of arc DE is also going to be 18 degrees. Okay, now if I look at this whole arc right here, AED, that is a semicircle, so it is half, it's going to be 180 degrees. So I can do 180 minus 18, and that is going to give me that this arc here is 162 degrees. All right, so now that I know all the pieces, that'll make this part go very quickly. So the first part I want to look at is the measure of arc CDE. So if I go CDE, that is going to be a 90 degree arc plus an 18 degree arc, which is going to be 108 degrees. Okay, 108 is less than 180, so this is a minor arc. Now, I want to bring something to your attention. Notice that this arc is named with 3 letters, but it's a minor arc. Here's why, because they want to make sure that you're going the right direction around the circle. Because until you actually calculate the degree, you don't know if it's a minor arc or a semicircle or a major arc. All right? So there are going to be times that you're going to see minor arcs named with 3 letters when you are finding out their degrees. Now, if you already know the degree, you should not see a minor arc named with 3 letters. Like if I said, okay, what arc is 108 degrees, you should tell me arc CE. You should not tell me arc CDE. Because again, we're trying to, at this point with this problem, figure out what the measure is. So because we don't know the measure, sometimes you will see those written with 3 letters. All right, again, that is just to make sure and to be very clear which direction around the circle you're going. Now, if we look at the next one, we will notice that it is just arc AE. There is no third letter. So sometimes you will see a minor arc named with 3, and sometimes you will see a minor arc named with 2. Again, only when you are trying to identify the degree. If you already know the degree, minor arcs should only be named with 2 letters. All right, so there is a little bit of a difference there. All right, we already found that the measure of arc AE was 162 degrees, and I'm just kind of going to write the way that we got that was by doing 180 minus 18. All right, so that gave us that 162. That is also less than 180, so it is also a minor arc. Now, let's look at the measure of arc BAE. So we're going from B to A and around to E. So that's going to be that 18 plus 162, and that's going to give us 180 degrees. So since it's 180 degrees, it is a semicircle. So the next arc we're going to look at is the measure of arc CEA. So we're going to start at C, come around to E, and then finish off around to A. So the way we can say this is we can say that this is 90 plus 18 plus 162. Or again, you can recognize that this is 90 and then D around to A is 180. It doesn't matter if you say 18 plus 62 or plus 180, whatever you want to think about. This is going to give us 270 degrees, which is greater than 180, so this is what we call a major arc. Now, please know that I don't expect to see this information when you are doing your work. It's just so that way you have it in your notes, so if you ever don't understand how we got something, you have it there. But when you are doing your work, as long as you have your circle filled out, you don't need to do this piece of it. You can just put the answers in here. All right? So if you have any questions, make note of it on your notes. And let's go ahead and look at our next set of theorems. All right. What we have here is within one circle, or this also works if I have one in each circle and I have 2 congruent circles, okay? So if I've got 2 congruent circles and I have 2 central angles in each, or 1 central angle in each one, all of this information works the same way. So if my central angles are congruent, then what this is saying is that the chords that are contained with those angles are also going to be congruent. If the chords are congruent, this is saying that the green arcs are congruent. If the green arcs are congruent, then the central angles are congruent. So basically, if your central angles are congruent, your chords are congruent, and your arcs are congruent. So if you know any one of those pieces, you know that all 3 are going to be congruent to each other. Okay? So, you know, here, if I know central angles are congruent, I know arc ED is going to be congruent to arc CB. I know segment ED is going to be congruent to segment CB. And then these 2 angles are going to be the same. So again, if you know any one piece, then you know them all, which is basically all that this is saying. So don't overcomplicate this. Please keep it easy in your brain. All right. This is one of those things that when you're looking at it, it's like, wow, that's a lot of information. But it's actually not complicated, so don't make it overcomplicated when you're working, okay? The next piece that we're going to look at is a little more complicated. All right, so if I have a radius and it is perpendicular to a chord, then it's going to bisect this chord. So this piece is going to be congruent to this piece. Now, this works if I have a radius or I have a diameter. Either way, I'm going to still get this piece here is bisected if it is perpendicular. Now, this part down here is kind of the converse. If I know that I have a segment JK that is the perpendicular bisector of another chord, then I know that JK is on the diameter, or JK is the diameter. It will go through the center. All right? So they're kind of converses of each other. If I have a radius that's perpendicular, it bisects. If I have a segment that's a perpendicular bisector, then that segment is a diameter or a radius if you only have part of it. Okay? So just kind of keep that in mind. And let's take a look at how we're going to use some of this information. So when we look here at A, I'm told that RS is congruent to UT. So those segments are congruent, which means that the arcs that are contained by those segments are also congruent. So that means that arc RS is going to be congruent to arc UT. So I can set 3x equal to 2x plus 27. All right, so I am going to subtract 2x from both sides, and I'm going to get x is equal to 27. Now, I want the measure of arc RS. So if I want the measure of the arc, RS was 3x, so it's going to be 3 times 27. So that makes the measure of arc RS 81 degrees. All right, so now we're going to go ahead and look at part B, where I have that circles B and E are both congruent. So that means that they are the same size. And I'm told that arc AC is congruent to arc DF. So now I want to find the measure of angle DEF, which is this angle right here. Well, if the arcs are congruent, that means that the angle measures are also congruent. So I'm going to set 7y minus 43 equal to 5y plus 5. So we're going to subtract 5y from both sides to get 2y minus 43 is equal to 5. Then we're going to add 43 to both sides, and we're going to get 48. When we divide both sides by 2, I'm going to get that y is 24. Now, I want the measure of angle DEF, which is going to be 7 times 24, so 7y, minus 43. Okay, so when we're looking here, the measure of angle DEF, when I put 7 times 24 minus 43 in my calculator, I am going to get 125 degrees. All right, so again, if you have any questions, go ahead and write them down. Please make sure, again, don't overcomplicate this. Don't make it more difficult than it needs to be. All right, so let's take a look at our next example. Now, I want to find the length of segment BD. So the first thing that's important to notice here is most of the time, you're not going to see this little blue dotted line. You don't have to erase it or anything on yours because we're going to bring it back in a minute. But I want to show you this problem without it at first. All right, so let's take a look. If I have segment AE is a radius. All right, my radius is perpendicular to the chord. So this is that last set of theorems we were looking at that says that these are going to be the same length. So if we can find one of them, then I can find the length of BD by doubling the length. All right? Now, my radius has a length of 5 here. So remember that any radius that I draw in will also have a length of 5. So when I'm looking at a problem like this, I want to draw a radius that goes to one of the endpoints of the segment. All right, so I can either draw in the radius AB or the radius AD, which now I'm going to go ahead and bring back for you. So now I know that this is 5. So remember, these are perpendicular. So when I look at this, if I just kind of look at the piece that I am going to highlight right here, at this triangle, all right, notice it is a right triangle. And this was not drawn very well. Here, let me try to make this a little better. Why can I not be here? All right, well, we're just going everywhere. Okay, so it's a right triangle here. So if I take this triangle and I draw it out separately, this is 3, this is 5, and I want to find this length. All right? Because if I find this length, then I can double it to get the whole thing. So we have a right triangle. We know 2 sides. We're missing one of them. So to find that third side, we're going to do Pythagorean theorem. So we're going to do x squared plus 3 squared is equal to 5 squared. So that's x squared plus 9 is equal to 25. Subtract 9 from both sides, we're going to get 16. Take the square root of 16, we're going to get x is 4. Again, if you know your Pythagorean triples and you see that 3, 4, 5 triangle, you can skip this step and just make a note somewhere that, hey, you knew a triple, all right? Makes life a lot easier not having to do this. But to find the length of BD, both of those pieces are going to be 4. All right, so it's going to be 4 plus 4, which is 8. All right, again, if you have any questions, go ahead and write them down. What I want you to do right now is to go ahead and pause the video, all right, and do these 3 problems on your own. Once you have completed the problems, go ahead and press play, and we will go through your answers. So go ahead and pause your video right now. All right, so go ahead, take a second and check your answers. So with part A, we know that PC bisects this angle, so that means those angles are congruent, which means their chords are congruent. All right, so we set those equal to each other, solve for x, plug x back into RT. In B, we have congruent circles and congruent chords, so that means that the arcs are congruent. So we set those arcs equal to each other. We solve for y, and we plug y back into Arc CDE. All right, and then for C, again, PS is a radius that is perpendicular to chord QR, which means that chord QR is bisected. We have a right triangle right here, which I drew separately over here. Okay, remember your radius here is 20, so I can draw in any radius I want, and any radius will always be 20. So I can draw in PR to get that the hypotenuse of my right triangle is 20. We do Pythagorean theorem, and I get 10 square root 3 is the length of this piece right here, as TR. All right, 10 square root 3 plus 10 square root 3 is 20 square root 3, and I can put that in my calculator. Now, you could have, because you see we're going to nearest tenth, you could have put the square root of 300 in your calculator and then just did times 2, and that would still give you that 34.6. You did not need to get these in radical form. However, it's always good practice. But again, you are going to nearest tenth in the long run. So if you put the square root of 300 in your calculator, as long as you did not round too early, if you just leave it in your calculator, do times 2, that will get you your 34.6. All right, if you have any questions, make sure you write them down, and I will see you guys soon. Have a wonderful day.